Hello everyone, and welcome to another video on the channel. Today we are going on a journey straight to the planetary system of Gargantua. That's right, the black hole from Interstellar. But before we get there, we first need to travel to Saturn and find our cosmic shortcut, the famous wormhole. So let's go. All right, on our way to Saturn, we get the full show. Saturn isn't just the ring planet, it's basically a crowded neighborhood. It has 274 confirmed moons, which is an almost unreasonable amount of moons for one planet to own. Some are tiny space pebbles with official names, and others are absolute celebrities. Titan has a thick atmosphere, and even lakes and seas made of hydrocarbons, while Enceladus shoots icy geysers from cracks near its south pole. Basically a cosmic ice fountain with serious, maybe there's an ocean underneath, vibes. And those rings, they're not one solid band. They're made of billions of chunks of mostly ice and rock, ranging from dust-sized grains to pieces as big as a house. In most places, they're surprisingly thin compared to how wide they look. So yes, Saturn is wearing the universe's biggest, fanciest accessory, and it's basically ultra-thin glitter. But today we're not here to admire Saturn. We're here looking for a wormhole. It can look like a black hole in the distance, but it's not here to eat you, at least not on purpose. A wormhole is a theoretical tunnel through space-time, like a shortcut that can connect two very distant regions of the universe. Think of it as the cosmos' secret subway. You enter here, and you pop out ridiculously far away without spending a lifetime on the trip. All right, after a long search, here it is, our wormhole, sitting right next to Saturn, just like in the movie. As we said before, it looks a lot like a black hole at first glance, which is honestly not the most comforting design choice in the universe. But unlike a black hole, its purpose is very different. Instead of being a one-way ticket to disaster, a wormhole is supposed to act like a bridge, connecting two incredibly distant points in space. In other words, it is less cosmic monster and more unreasonably advanced shortcut. We enter the wormhole, and almost instantly we emerge somewhere else in the universe, already very close to Gargantua, the supermassive black hole. In theory, it has a mass of about 100 million suns, which is exactly the kind of number that makes space feel a little less welcoming. There it is, gigantic, monstrous, and absolutely not the kind of object you want to approach too casually. Once you get too close, nothing escapes its gravity, not even light. And here is the important correction. That point of no return is called the event horizon. The bright, glowing structure around it is the accretion disk, made of superheated matter spiraling inward at enormous speeds. So, to put it simply, the event horizon is the boundary where escape becomes impossible, and the accretion disk is the blazing ring that makes the whole thing look even more terrifying. And right over there is Miller's planet, the world orbiting closest to Gargantua. Let's land for a moment and take a look at what the view is like down there. But we really do not want to stay long. On this planet, 1 hour equals about 7 years on Earth. So yes, even standing still here is basically a very aggressive form of time management, and it is an extremely dangerous planet. Its surface is covered by shallow water, but the real problem is the gigantic waves formed by the immense gravitational influence of the black hole. In a way, it is similar to how the moon affects Earth's tides, except here the effect is pushed to a completely terrifying extreme. Instead of gentle rising seas, you get walls of water that look less like waves and more like the ocean itself deciding to stand up. All right, it is definitely time to leave. By now, several months have already passed here, which is exactly why admiring this place from a safe distance suddenly feels like a brilliant idea. The view is undeniably beautiful, but it also has that special kind of beauty that quietly tells you it could destroy you at any moment. So yes, breathtaking, but also deeply unsettling. Let's move on to the next world, Dr. Mann's icy planet. Dr. Mann's planet is a bit farther from Gargantua, so the black hole's gravity is not hitting as hard as it does on Miller's planet. But don't get excited. This world is basically ice, cold, and disappointment. It has an atmosphere, but it is not like Earth's in a safe way. In the film, it is described as containing ammonia, meaning you cannot breathe it, and the good news, Mann reported. We later learn he faked the data to get rescued, so the conditions for life here are extremely poor. Leaving Dr. Mann's planet behind, we now head to Edmunds Planet, another world that appears only briefly at the end of the film, with very few details revealed. What we do see, though, gives the impression of a dry, isolated, and somewhat mysterious planet. In theory, it may be the most promising place for life in that system, but let's be honest, it still feels a little suspicious. Maybe we will only know for sure if the movie ever gets a sequel, which at this point might arrive only after we survive another trip through a wormhole. But enough of these planets where life is only a possibility on paper. Let's go somewhere we actually know is fascinating for real. Titan, Saturn's largest moon. And that is where our journey takes us next. See you soon, everyone.